This image gives us a clear understanding of the forward-biased diode, a very fundamental concept in electronics. Let's begin with the symbol of a diode, shown at the top. A diode is a two-terminal semiconductor device that primarily allows current to flow in only one direction. It has an anode, the positive side, and a cathode, the negative side. In the symbol, the triangle represents the direction of current flow, pointing from the anode to the cathode, while the vertical bar represents the blocking direction. The arrow labeled I shows the direction in which conventional current flows from the anode to the cathode when the diode is forward biased. Now let's look at the circuit diagram below, labeled forward biased diode. Here, we have a battery connected such that its positive terminal is connected to the anode of the diode, and its negative terminal is connected to the cathode. This is called forward biasing the diode. Under this condition, the diode allows current to pass through it, just like a closed switch. That's because the forward voltage from the battery overcomes the barrier potential of the diode, which is typically around 0.7 volts for silicon diodes and 0.3 volts for germanium diodes. In the circuit, there's also a resistor labeled R, which plays an important role. It limits the amount of current flowing through the diode and the entire circuit. Without this resistor, too much current could flow when the diode starts conducting, potentially damaging the diode or other components. When the diode is in forward bias, as shown here, the electrons from the N-type region, which is closer to the cathode, and the holes from the P-type region, near the anode, are pushed towards the junction, where they recombine. This movement of charge carriers creates a current that flows through the external circuit. The diode offers very low resistance in this mode, and current increases rapidly with voltage after crossing the threshold value. It's important to note that if we reverse the battery, that is, connect the positive terminal to the cathode and the negative terminal to the anode, the diode would be reverse biased and block the current, acting like an open switch. In summary, this image shows how a diode works when it's forward biased. The correct polarity of voltage allows it to conduct current. This behavior is used in many real-world applications such as rectifiers and power supplies, clipping and clamping circuits, signal demodulation, and even LED operation, where light is emitted when the diode conducts.